This is the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It looks rather complex, but what it is a formula that will solve any quadratic equation if you simply substitute in the correct values of a, b, and c from the given quadratic formula that you're trying to solve. This formula is a nifty tool to have in your tool belt. I ask students to learn it and memorize it because it'll be useful not only this year but in future math courses. I typically have them sing it to Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Unfortunately, we won't get to go caroling during FIT to other classrooms and bless them with our wonderful singing voices. To solve an equation such as this one, 2x squared minus 11x plus 12 equals 0, we could solve this using the quadratic formula. Here's how. Our steps are, first, make sure the equation is in standard form. You might start the question in standard form, or you might have to manipulate the equation to get it there. Step 2, identify your a, b, and c values. Step 3, substitute your a, b, and c values into the quadratic formula. Step 4, simplify. And then when you're done, verify that your solutions are in fact correct. So we come back to our equation in question. We're asked to solve this quadratic equation. What we're going to first do is identify a, which is the number or coefficient in front of the x squared term, 2. We're going to identify b, which is the number or coefficient in front of the x term, which in this case is negative 11, and c, our constant term, which in this case is 12. We're then going to substitute a in for both of the a's in the quadratic formula, the b in for both of the b's in the quadratic formula, and the c in for the one location where there's a c in the quadratic formula. So we'll go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, the b values are going to be substituted in to the two locations where there's a b. The a value will be substituted into the two locations there's an a. And the c value will be substituted into the one location there's a c. From here, we simplify. Negative 11 is 11. So now it's x equals 11 plus or minus the square root of, well, negative 11 squared is 121 minus 4 times 2 times 12. 4 times 2 is 8, and 8 times 12 is 96. All over 4, and that comes from 2 times 2. From here, we continue to simplify. X equals 11 plus or minus the square root of 25 all over 4. 25 comes from 121 minus 96. Back the camera up here. Next, we'll take the square root of 25, and we get x equals 11 plus or minus 5 all over 4. This plus or minus has probably been a little bit confusing for you. It's because there's potentially two solutions. One of our solutions we will find by doing 11 plus 5 all over 4. And the other one we'll get by doing 11 minus 5 all over 4. So when I say plus or minus, I mean do it once with a plus and then do it a separate time with a minus. 11 plus 5 is 16, so this becomes 16 over 4, which is 4. And 11 minus 5 is 6, so this becomes 6 over 4, or 3/2. Those are our two solutions. The solutions to this quadratic formula are x equals 4 or x equals 1.5, which is the same thing as 3/2. If I take 4 and plug it back into the original equation for both x's and simplified, I would get a true statement. 4 squared is 16, doubled is 32. 11 times 4 is 44. 32 minus 44 is negative 12, plus 12 is 0. That's confirmed. The same would be true if I took 1.5 and plugged it back in. What this means, friends, is that this parabola of this quadratic equation up here, the 2x squared minus 11x plus 12, has x-intercepts, or roots, or zeros at these two locations, once at 4 and once at 1.5.